Getting started? All right. I have to check it from time to time because I was doing the same thing with my other class, with my CISA 141 class, and for some reason the recorder just kind of cut itself out within 20 minutes or so.
I couldn't tell how to read for the exam too. I couldn't tell how to read the grade.
The grade?
The line by line.
Yeah.
I couldn't tell how to read it. I thought it didn't add up right. It didn't look like it added up right.
Well, I will take a look. Send an email to me, and mention this class name and.
Yeah.
Yep.
I know
Does anyone else have the problem? I mean, do you observe that your grade does not add up for exam 2?
Yeah, so I counted up the.
Okay.
If it added up wrong, don't fix it.
Does it add up wrong in your case?
Yeah.
I don't think so.
You don't think so?
I added it up, but it didn't come out to the right numbers.
Okay. Well, there's a multiplier for each number, and then so you have to multiply what you get with the weight of each part to become the score of that part, and then add up all the scores.
I did. When I added it up, like if I got everyone correct, it added up to like 32 and not 42. It's weird.
It might be scaled too. Remember, I had to scale the whole thing. One question was marked as extra credit.
Right.
So that means your score is 1.333 times the actual original score.
Right.
And that's why it looks different.
So like if mine said like 25 out of 42, that's not it.
That's the class rank.
Huh?
That's your class rank. There's 42 people in the class.
Yep. So that's your class ranking, which
That's
means
not your score.
And then there's another part that wasn't just looking at.
Yeah, the 25 out of 42 isn't your score.
That's your
what
ranking.
Your placing is.
Right. No, there's another one that I'm thinking of not using that as an example. That's the number I can recall, but there's another set of numbers where you.
Okay, I can't really see it here, so we'll defer that discussion. All right.
So,
Yeah.
when is our final?
That's what I'm going to look up right now, is to find out when your final is going to be.
Oh, it's 20th.
Well, I'll double check. I'm just going to double check, make sure that I don't make a mistake with that. So I show up and nobody shows up, for the final exam.
20th.
We get to have our final, and then we all get to die.
Wait, isn't that the 21st?
All right. I don't know what the computer is doing. It's not doing what it is supposed to. I'm having networking issues.
I was actually
Right.
Okay. Now it's good again.
It's the same thing as saying, okay, it is the end of the Iron Age. You are now into this
Oh, it's on the homepage.
It's the same
Yep. I guess it's important for people, right? Okay, so this is how we look up the final schedule. It depends on the start time of the class. So this class starts at 10:30. In other words, it's between 9:30 and 10:40 a.m. and it's on a Tuesday, Thursday. So that means our exam is next Thursday. We have more than 1 week from today, and the time is 10:15 to 12:15. It's a 2-hour exam. I will arrange this class to go to the computer lab so you can actually do the exam online, unless you guys prefer paperwork.
No, for God's sakes.
Okay. So we'll probably do it at the lab.
Can we just do it at home?
No. Has to be face-to-face, has to be proctored. Yes. So there you have it.
So we would just go at 10:15.
To room 152. So I will disclose more detail on Thursday, once I confirm that we have the space to do it.
I like it.
All right. Are there any questions regarding, when the final is going to take place?
When will you know if we can do it in the computer lab?
Sorry?
When will you know if we can do it in the computer lab?
By Thursday. So I have to talk to the lab technicians, make sure that they have enough space on that day for the exam. I think this is the last day.
And Thursday we'll find out when.
Sorry?
Right now we know when. Thursday we'll find out where.
Yes, it will be in the computer lab, 152. It will be in that lab. Yep. All right. So any other questions about the final exam?
How many questions?
How many questions? It's going to be scaled the same way as your exam 1 and exam 2. Your exam 1 has 80 minutes and so does your exam 2. So the final exam will just be proportionally more questions because we have 120 minutes. So that means we are going to have 50% more questions.
But you don't have any questions on the second review.
Buy 2 get 1 free. Sorry?
Oh, the Capital One commercial with Jimmy Fallon, the little baby.
Oh,
Could help you in that.
I don't watch TV, so commercials are kind of completely out of context for me.
Are we going to review?
Yes, we will review on Thursday. So today we'll kind of finish up some of the things that we were talking about, the object-oriented programming stuff. What?
What are we doing then next Tuesday?
There won't be class next Tuesday. Thursday is our last lecture of the entire semester.
Okay, so this Thursday is the last lecture.
Yes.
And Tuesday we don't have to show.
That is correct, unless you have exam
The
on that
final
day for
week
your other
starts
classes.
Friday.
Yep, exactly. The final week starts on Friday, so Thursday is our last day of instruction. So in terms of lectures, that's our last day. Sorry?
After Thursday's the last day of instruction for the entire school. After that, it's final.
Exactly. Yep. There will be no more classes after Friday. Yep. Okay, so are we okay with that? Okay. That's the kind of stuff that you need to know, like, when you sign up a class, because you need to know when the finals are going to be, to make sure that you won't have anything else, on that week, in that week. Right, so now that we are done with all this stuff, we'll continue with our discussion of object-oriented programming, which is something that we talked about last time. So we'll go ahead and open up the document that I typed up last time. Oh, before I forget, also this is important. The professor who's supposed to do this, forgot to tell me about it. So I'm going to do a little search here and see if I can find it. Anto cisp480. He's supposed to have, told me and give me a URL to his website. How many people have tried to sign up for cisp360, but you could not get into the class?
It was closed before the.
Okay, that counts. Yes, that counts as that qualifies. All right. So what you want to do is to look into cisp480 in the next semester. So let me just go to the class schedule, and then we'll go from there. It's really slow. I don't know why it's like exceptionally slow right now.
Owner class?
Hmm?
Is that the owner class?
It's not an online class. It's an honor class. Yes, it's an honor class.
Isn't it in conjunction of this class and then the PG?
It is a conjunction. Yes. Okay. So let me go there and we'll talk about it. Okay.
Academic.
Or that, but it's exceptionally slow. I'm not sure whether it's my computer, which I really don't think is the case, or the network itself.
Your computer is part of a botnet.
Botnet. But I did work with my live Linux distribution. If this continues to be slow, I'm going to use my 4G connection.
Faster.
Yeah, I can tell the IT department go like, "Your computer is so slow, I have to use my 4G connection. It's still faster." All right, so for next semester, most of you probably want to get into CISP360, and many of you probably fail to get into that class, and some of you probably cannot even get onto the waitlist, right?
Yeah.
How many people could not even get onto the waitlist?
It was closed by the 28th. No wait.
Yeah, that is really sad. Yeah. Well, it's a good thing that Prop 30 actually passed. So if it does what it is supposed to do, then we'll be. I think we're bottoming out in terms of getting classes cut and stuff like that.
Yeah, I heard they're hiring on some adjunct and overload professors next semester.
Sorry.
said they're hiring on some adjunct and overload professors.
Yeah, well, it depends on the classes. You know, a lot of the programming classes, we only have full-time professors teaching those.
Yep. Tech, do you think, well, because of Prop 30, do you think they'll bring back the systems programming in Linux? So the class you were teaching?
That probably won't be back, anytime soon, unfortunately. But you do need to take a few other classes first. So hopefully, by the time you're done with those other classes, we might be bringing 453 back. It's hard to say. That one is really hard to say, because 453, CISP 453, is only applicable when you're transferring to a CSU, particularly Sac State, but it's not recognized by the UC system, and that's why the enrollment of that class is really low usually. And now that productivity is important, when the departments and areas have to report in, the administrators will look at our so-called productivity, which is basically the number of student contact hours per professor.
So do most CS majors that kind of transfer, do they transfer to UC Davis?
They transfer to all CSUs and UCs, but the thing is, if you do not take that class, you can still transfer. It's just that you have to take it once you transfer. So you might have one class that you have to take at Sac State, because we cannot offer that class here. But from past experience, they might have problems offering that class over there too.
Yeah. Kind of scary.
Yep. Okay, so this is the class that I want you guys to kind of take a look at, especially when you try to sign up for CISP 360 and you are really at the bottom of the wait list, or you could not even get onto the wait list. So I'll just kind of read out the requirements here. The only prerequisite here is placement into English Writing 480 through the assessment process. And this has nothing, absolutely nothing to do with the CIS department or the BCS area. This is a requirement of all honor classes on campus.
It says placement. Does that mean you have to take it?
Yes, you have to take a placement test first, and then the result of your test has to indicate that you have a placement to that particular level of class.
So you don't have to take the class first, you just have to be eligible to take that.
That is correct.
Okay.
That is correct. You have to go through the placement test, the assessment, and the assessment result has to indicate that you can start with English Writing 480. Yep.
This class is waitlisted.
It is already waitlisted?
Yes, it is.
That's why I
Now,
already mentioned
the
it.
chances of this class, having more opening within the first few weeks or so is higher, because a lot of people forget about the prerequisite. So as soon as the instructor checks the prerequisite, it is possible that many people will say, "Oops, I didn't read that part," and they cannot, take the class. So if you cannot get into a class, like CISP 300, 360, and versus this class probably has a better chance of getting into it, even though it is full and the wait list is closed.
Like any of the classes, like this one or the P360, what do you need to do to show that you completed the prereq, like for let's say the P360?
We can see that,
Okay.
when we look at a class that has prerequisite, the computer system, the roster system, actually shows a list of students who have fulfilled the prerequisite requirement already. So what we need to do, on the professor side, is we actually have to do the subtraction thing and find out who has not have the prerequisite yet, and then those students, we sometimes have to drop this.
Okay. So we don't need to bring anything. You guys just
No,
check
there's
it.
nothing you have to
Okay.
bring in. If you pass this class with a letter grade of C or better, the system will automatically reflect that you have fulfilled the prerequisites already. All right. Any other questions about classes that you might want to take or consider next semester? So it looks like all the programming classes are full. Everything that you guys want to get into, they're all full. That's not good. That is not good. How can that be the case? I mean, we have one, and then we have, what, 2 sections here or 3 sections?
It's actually just one class.
That's one class per professor.
No, those are 3 classes. Look at the numbers on the right side.
But you can only count the lecture hours.
Right. Yeah,
Those are
okay, yeah,
labs.
3. 2 by.
Yeah, those numbers are all lecture numbers. So they're basically 3 lecture classes.
And then you
But
can
these are
compare
smaller
the lab.
classes, especially if you see the room number. Okay, let's see. You do have, room 126. and 152B, those are all labs. So that's why 121 is this classroom, so it's not a lab classroom. But anything that has a lab component, they limit the enrollment to the capacity of that room, which is typically about 30. On top of that, each professor can kind of specify an upper limit in terms of enrollment. Like with this class, I kind of just opened it up to the capacity of the room. That's why we have a lot of students here. But in many other classes, the professor can specify like 30. So even though the room can accommodate more than that, but because of the workload and other factors, the professor can say, I can only handle up to 30 students. And that's why even though we have 3 cisp300 classes to feed into 3 cisp360 sections, and that's why we still have students who cannot get into those classes. And then plus students who have to take that class again, so those students will also be taking up spots too. And that's why sometimes it's kind of problematic.
Those on the wait list, if someone who's already in the class doesn't fulfill the pre-reg, you get a spot.
Right. Yep. So you still want to get onto the wait list if you can, or if you cannot get into the wait list of any of these classes, you can still show up and see whether the professor will let you stay in the class until there's an opening. The chances of getting into a class without being even on the wait list is not much. Okay, because these days people don't drop their classes like before. Even with this class, this class would start with about 40 students, on day one, and by mid-semester or so, I would have about 25 left. That's not happening this semester. Has not happened for a few semesters already. So that's going to be the same situation with cisp360 as well as your other classes. And I have no idea when that situation will start to kind of taper off and
It might help if there's more classes for people to spread out in.
Yeah, but to have more classes, we need the FTE to come from somewhere. And it's always a juggling act. The CIS department is not only teaching programming classes, which most of you are only interested in. We also teach application classes. We teach core classes, computer networking classes, and security classes. So if we offer more programming classes, those units, those FTE allocation, they have to come from something else. So some other classes will have to be, trimmed in order to. Sorry? New teachers. It's not about teachers. We have enough teachers, we can get enough adjunct help to help us with teaching more classes. We don't have enough allocation of units. We don't have enough allocation of FTE or full-time equivalents to offer classes. That's the problem. That really is the bottleneck. Does everybody understand what I'm talking about?
Politics.
A part of that is politics. Yep.
Yeah, let's talk to their professors.
So apparently I did not say. Oh, okay, that was from the previous class, and we want the latest one. All right, so we'll go ahead and I used the wrong software to open it. Do it again. All right, so we are getting into object-oriented programming. Remember that? And what we'll do is we'll look at shapes 2. That's not what I did. Okay, I might have just saved the text file without a folder. Yep, there we go. Yep, there we go. That's this is the last thing that we did on last Thursday, and the point that I was making was, why do we want to kind of get concerned about how a point is represented, the coordinate of a system? You guys kind of remember that? I was telling you guys, how you can get a light bar on bicycles, to attach to the spoke. So when you ride your bike, the light bar will rotate, and because of the persistence of vision, if you blink the lights, on the light bar in a certain way, you can actually start to see images, coming out of the bicycle wheel. Sorry?
Pac-Man and the Ghost.
Pac-Man and the Ghost, exactly. So that was the example that I was using. But the whole thing was basically explaining why you may not want to use the XY coordinate system, and sometimes you want to switch to a polar coordinate system, an angle plus a radius. Remember that? Okay. So what does that have anything to do with programming? Well, let's think about it. Now, if you look at this program, I'll just go from the beginning part here, and we'll go ahead and define what a coordinate is. Okay, so we'll say record type coordinate. I'm defining my own type here. And we'll say, we have x, y as integers. Okay, this is a fairly common way to say, okay, this is how we represent, coordinates in a 2D space, right? So now that we have this, now that we know what a coordinate is, we can go into, this part here, and then we can start to say, r dot, what is r here? R is a rotatable shape. A rotatable shape has a shape as an attribute, as one of the attributes. So we have attributes as a as a member, and then within attributes, an attribute is a shape, and within a shape we have a center, and within center we have x and y. So now we can go back to the test code here. I'm sorry about this part here. So attributes dot center dot x, and we can say, okay, we want to go to x to specify 5, and we want y to specify 0. Okay, so my point is to say, there is something wrong with this approach. In other words, directly accessing a member of an object can lead to problems. Something as simple as these two lines can be problematic. Okay, now why would that be problematic? Well, I'm going to explain that later. But before I explain why that would be a problem, I'll just kind of talk about a way to fix that problem first, and then we'll go back and talk about why there is a problem to begin with. So in this case, this is not even object-oriented programming. And I can just say define sub set coordinate, and define sub. Set coordinate is very simple. It has one thing that's passed by reference, which is a coordinate. And then it has two things passed by value. So I'll set set coordinate xy. The two passed by value parameters will be x and y, and they're both integers. And then the only thing this is going to do is to say c.x get parameter x, c.y gets parameter y, and that's it. So that means instead of using assignment statements within the test subroutine, I can also do this, right? I can say invoke set coordinate xy, and I use r dot attributes dot center to specify parameter c. I use 5 to specify parameter x, and 0 to specify parameter y. So when you look at this way, this subroutine call is going to accomplish exactly the same thing as those two other assignment statements. Is that okay? Does everybody see how we can accomplish exactly the same thing? Okay. So the question now is, why would I want to define a subroutine, set coordinate xy, like this one, and use a subroutine call to accomplish something that could have been done with simple assignment statements? That is the question. Why do I want to do something like this? Now, because I'm asking that question, because you will have that question too when you take an object-oriented programming class, because it seems like I'm doing a lot of extra work for no reason whatsoever. Okay. So now let's go ahead and imagine that you have code like this sprinkled around the entire program. Okay, because that's the only way, that's the quickest and easiest way, and also dirtiest to access individual members of a particular object. So you have all kind of code like this sprinkled, into an entire program. Let's say you have 500 lines of this kind of stuff, everywhere. All right. And then your boss comes in and say, you know what, that little program that you wrote, to draw something with, LED matrix, I want to change that program so it works on the spoke, setting too. Now you have a problem, because in terms of the representation of the dots, you need to change the polar representation. Okay. So what happens is, in that case, the first thing you need to do to change your program is to go back to this representation here and say, oops, this is a thing of the past, so you have to kind of comment it out. Okay, in C++, bar / is the beginning of a comment. In other words, this line is no longer interpreted by the compiler. And then you have to change it to the angular coordinate, which is theta, which is probably a real number, as well as radius, which is also a real number. Okay, that's a simple change. 2 lines of change here. But the downstream consequence of this is significant, because guess what? You have 500 lines that directly access X and Y sprinkled throughout your entire program. And all those 500 lines will now have to be modified. Is everybody getting the point? Okay. The math is not even important here. How do you convert from XY coordinate to the angular coordinate? That part is not important. The fact is you have 500 lines to modify. Okay. What if you have 50,000 lines sprinkled? Then you have to modify all 50,000 lines. So the question is, sorry?
Or you just find a tall building to jump.
You can find what? Sorry?
A tall building to jump from.
Yes, you can do that.
That'd be too long.
That will not be very productive.
X
All right. Or you can think, what would have TAC done in this case, right? Okay, so what TAC would have done is to do something that I just did. Okay, so what I would do is I'm going to use a subroutine before I sprinkle all this code around. I'm going to define a subroutine like this, set coordinate xy, and throughout the entire program, I will have 250 subroutine calls like this. Okay, but TAC, don't you still have a problem because we are still changing the representation of coordinates? The answer is yes, I still have lines that I have to change. I got 2 lines that I have to change and I'll be done. Why? Well, this is the only part, if I program consistently that way, this is the only part that I refer to the x member and the y member of a coordinate. So if I fix this part by saying, oh, you know what, this is now in terms of theta and radius, now I can just change this part. Theta, if I remember correctly, this is arc. Let's see, we have xy, so this is arctangent of x divided by y. And a few other tests, because you can get infinity when it's 90 degrees and stuff like that. Okay. And stuff. Okay. And then the radius is the square root of x times x plus y times y. Okay? Okay, and stuff can be a little bit more complicated, all right? But nonetheless, it is still only one place that I have to change. What about those calls to set coordinate xy, like this one here? Don't you have to change that too?
Nope.
Nope. I'm done. Okay? Does everybody see, without actually worrying about all the details and stuff like that, does everybody see the point of this whole thing? Using a subroutine to access individual members instead of accessing the members throughout the entire program. Because the subroutine is now one level of indirection, it's basically kind of like a mask or shield so that you can change the underlying representation without changing the actual subroutine calls. And that's why it is useful. Okay? If you're having problem understanding this concept and cannot really follow the code, because there really is quite a bit of code, and over the weekend some people might have forgotten what we talked about on Thursday. There's an easy analogy. Okay, most of you are still old enough to remember CRTs, right? The old television technology. You still have one? Okay. My dad has one of those, 30-inch, CRT TVs, and it's sat in the living room for half a year because he could not move it to the basement until me and my brother went home. And even with the three of us, it was kind of it still took a little bit of work to get that thing downstairs. Okay, so that's CRT technology. And then we move on to plasma, and then we move on to LCD technology. Here's my question for you. Do you have to understand all that technology to make your TV work? Do you have to open up the CRT the back of a CRT TV and tweak the capacitors and resistors and stuff like that to make it brighter, more colorful and stuff like that, to change the color saturation?
If you want to get electrocuted.
No.
Only if you want to.
Do you have to understand, how a CRT works? Like how the how you can accelerate the electron, using the high, charge, of the electron gun, to make it brighter. You're basically increasing the velocity of the electron when it comes out of the electron gun, and to change direction so it has a little sweeping motion, you have to use magnetic coils, right? To kind of deflect the electron so it becomes a sweeping motion. Do you have to understand all that physics stuff?
It makes it more enjoyable and more satisfying to use the machine if you know how it works, but you don't have to understand how it works.
Exactly. Okay.
Probably not all that many people anymore that know how that works.
It's fun to see it work, though. I mean, and that's also why CRTs are so heavy. It's because inside that tube is a vacuum, or as close as they can get. There's no absolute vacuum. So, but it's basically vacuum. Yep.
So, what's the difference between the LCD and LED?
Oh, that's completely different. LCD stands for liquid crystal display, and LED stands for light emitting diode. So they even share a single word, even though the short form, the abbreviation, looks about the same. They're completely different. So, well, let's talk about it, right? I'm turning this into a physics, engineering class, right? Okay, LCD stands for liquid crystal display. You have a light source of some kind, and some, in the old technology, we usually have fluorescent lights, as a backlight. New technology uses LED as a backlight of LCD. So LCD, you have a light source. I don't care how you do it. You can use candlelight if you want to. Okay? So the lighting, the backlit technology is completely separated from the actual liquid crystal display technology. So the first thing it does is it goes through a polarizer. Okay. In other words, when you see light, the way we see it, they come in different directions. In other words, some can come in like a slanted angle like this when it oscillates, and some can come in like this, some can come in like this, some can come in like this. The polarizer, what it does is, if originally everything can be in any direction, everything that comes out of this is in a particular direction. Let's say vertical can come out. Okay, anything that's not vertical will either be attenuated, which means it's lowered, or completely cut off. Okay, so before you have all kinds in different orientation, when it comes out, it's all in one single orientation. So this is the first part. The second part is the actual liquid crystal display unit, which consists of two plates. Okay, between the two plates, you can apply a voltage, okay, a certain electrical potential, and what that does is it can align tiny little crystals suspended in liquid, and therefore the name liquid crystal. What that does is, crystals, when they're aligned in a certain way, they also become a polarizer. Except in this case, you can say turn on and turn off. When the LCD, when the liquid crystal, when there's no charge applied here, then the liquid crystals are basically arranged randomly, so they will allow any type of light to pass through. When you have a voltage here or electrical potential here, the liquid crystals will start to align, and when they align, they become a polarizer. So this, when it becomes a polarizer, it will be opposite to this one here. So this light here will stop basically here, and no light is coming through when you apply a voltage across the two membranes here. Okay. In other words, you have a way to decrease the light coming out of the light source. Okay. You can either turn this on so that no light comes through, or you can turn it off where you have some light coming through. And that's how each pixel works with an LCD display. Are we doing okay? Does that sound very inefficient to you?
Yes.
Because going through the first polarizer, you lose at least 50% of the light already. Going through the second one, even when the LCD is off, you only get up to 50% of the remaining amount of light. So what you're seeing from your screen is at the most 1/4 of the actual backlight source. And the other 2/3 are wasted as heat. It's heating up the polarizer, it's heating up the liquid crystal itself, and it's not transmitted as light. And that's why LCD displays are very inefficient. And that's also why on your cell phones and also on these displays on a laptop computer, that's the biggest power drain of everything. Has anyone checked your phone, to check, how your battery energy is used? With mine, typically 50% goes to the display itself. The cell phone, the processor, and everything else will make up the other 50%. Okay? Yep.
So this voltage between them can relate to the frequency that we set up on a, for example, computer to make
No,
it
that
better.
part is that has to. This is the physical part of it. When you look at the refresh rate of an LCD monitor, it has to do with how quickly you can realign the liquid crystal. So that part is a material science thing, because with different material, different crystals, and different thickness, that will change the response time. So that has very little to do with the actual physics of it. So this is how it works. The next question is, this is a big, huge digression, obviously. Did you have to understand this stuff to make your LCD screen and LCD TV work? No. How about plasma? No. What about the new, whatever technology TV that we'll see in the next 5 years? No. Right? What do you use to change your, to change the brightness, color saturation, and stuff like that of your television?
The menu control.
Right? And has this changed, dramatically over the past 20 years?
There's just a few more
Oh,
buttons.
20 years? Sure.
20 years.
Yeah, well, okay, 10. 10, okay? Well, most TVs and most projectors have on-screen display, so you basically just, press the menu button, and this is how you change everything. Do you see anything here that might pertain only to a particular technology, LCD versus, what is the other technology for projectors? Digital light processing,
Yeah,
DLP. Does anything here remind you of the technology behind it? For all we know, there could be little magical creatures, painting the picture in the inside of the projector. As long as we can control all this stuff here through the remote control, who cares?
DLP is pretty
Right?
cool how DLP works.
Who cares? So, what do you think this has to do with the topic that we are talking about right now?
Now, what's
This
the difference between interlace?
Is a remote control button. This is a remote control button, and this is the actual technology behind the scenes. Okay, that's the difference. This stuff can change dramatically depending on the implementation, how you're using the software, the display technology, and all of other things can affect this part here. But as long as you have a button, call this name, and throughout your own program, throughout your code, you're only pressing the buttons instead of opening up the case and trying to tweak things inside the projector, you'll be fine. In other words, there's a name for this type of programming practice. It's called, my mind is going blank here, abstract data type, ADT. Okay. Now the term abstract data type is not really used anymore because over time it got morphed into object-oriented programming. But that's how object-oriented programming got started. Okay. It is from abstract data type, or ADT, that we start to think about, how do you write software? This has nothing to do with the feature of a program. Okay. I can apply this type of technique in any type of programming language, including programming languages that have no types whatsoever, like assembly language programming. Because this has to do with how you look at things and how you can say, okay, I want to make a layer, like a certain layer of software, where beyond this point, it has nothing, it is insensitive to the actual implementation. And below this point, we actually need to know the underlying implementation. You're making an artificial membrane around, certain parts of the program. So one change inside the membrane does not affect the outside of the membrane. And this is also known as the API, or Application Programming Interface. Yeah.
Like with Android for developers.
Yeah. So as long as you play by the rules and only use the API that is published, Android can upgrade all they want to version 10, 11, 12, whatever. They have to find all the pastry names to fit all the different versions too.
Pastry names.
Yeah, pastry and sweets names, right?
Jelly bean, what's the next one gonna be?
Okay, sweet stuff. How's that? Twinkies. But Twinkies is already trademarked. They cannot use it.
Unless they buy and host us.
There you go.
And Google may just do that, just so that they can get the name Twinkies, right?
There you go.
I'm gonna get Android Twinkies. Yep.
Hostess too.
Yep. But as long as you play by the rules and only use the published API, for all we know, in the next 5 years, Android will be 3D capable, right? And you don't have to change a thing if your program and your application can stay in 2D. Because what happens is, the 3D thing is an extension of a 2D thing.
It'll be connected to the glasses, so.
Yep. But you don't have to change the thing as long as you play by the rules, the API. All right? Are there any questions about this particular programming practice? This is not, once again, this is not a programming language feature. Okay, the programming language does not say that you have to use this feature, or else there will be compilation errors and stuff like that. It is you as a programmer choosing to write your programs this way, and you will find that there are a lot of techniques and tricks like this, where you can do things in many different ways, but certain ways make your programs more manageable down the line. Okay, are we doing okay so far in terms of concepts? Now, most of you probably throughout your 3 years here, even though it's supposed to be 2, most of you probably take 3 or 4 years to get through all the classes, because we cannot offer as many classes as we need to. But anyway, throughout your entire school years, okay, including your college and universities classes, many of you will not appreciate what I just said. Okay, you will write your 500-line program and go like, who cares what tech has to say about abstract data type, or creating all these membranes and protecting changes from this part of the program so the other parts won't get affected. Because why? You're only dealing with 500 lines of code, not 50,000, not 500,000, or 5 million lines of code, written by people like all over the world, and some people have passed away already, right?
Linux.
Okay, you don't have to worry about maintenance of your program. Now, once you start to work in the real world, then this becomes important. Okay, because without using this type of technique, programs will become very unmanageable. Okay, over time, there'll be more and more stuff, and this technique here, okay, the lack of this technique, when your program starts to refer to the members of a structure or the members of an object directly, this is called, this kind of program is called brittle. In other words, it can be broken very easily. Okay, one little change to the underlying representation, and you have a lot of stuff to fix in your program. If you do it the other way, play by the rules, then you have isolated your code from changes to the underlying representation. Yep.
Don't most languages allow that?
You can, if it is your type to define, there's always a way to get around it. Because in C++, you can mark members as private, protected, and public. And most people, for convenience, sometimes they would just say, well, I don't want to bother to create a subroutine to do it. I'll just go ahead and make a member public so that it's easy to kind of tweak the inside of a structure. And that's the first mistake, making things public when they're not supposed to be.
But if you don't mark it, isn't like private automatically in most languages?
Yes.
That's what I understand.
Yep. it's automatically private, but making it public is just one word, in the definition of the type. So unless you're inheriting the code from somebody else, most of the time, it's very easy for people to kind of bypass, that feature of an object-oriented programming language. All right. So are we doing okay so far with why this approach is useful, even though you guys have not written any programs that require this type of organization? Sort of. Okay. I have personally dealt with programs that are poorly organized, so I have been the victim on the other side of the fence. So I really, really appreciate this kind of programming practice. All right. So getting back to real object-oriented programming. So we are getting back to OOP method here. So we have coordinate, stuff like this, and you can see how this also kind of do the same thing here. Set xy of a coordinate type is doing the same thing as set coord xy, except in this case it is a method. The subroutine becomes a member of the definition of the type. In C, C++, and object-oriented programming terms, it becomes a method. A subroutine that is a member is also called a method of the record or class definition. Okay, so we have some other interesting things here. We have a rotatable shape, we have a line, and we have various things that we can define that are shapes that you can draw. So now let's think about a different scenario. Let's think about a scenario where you have an array of these various shapes they can draw on the screen. And you want to go through the entire array and say, okay, for each shape, I want you to draw yourself on the screen. Okay? And that's going to be a problem because we don't have an array of circles and a different array of rectangles and a different array of lines and a different array of squares and so on. We want to use one single array for all the different shapes that we are supposed to handle. Are we doing okay so far in terms of concept? But that's kind of problematic because with the concepts that we have, we already understand at this point, that's not possible. Because what we are trying to do is something like this. Okay, what we are trying to do is to say we have a local array. So we'll just say this is an array of some kind. And what we want to do is to do something like this. To use our usual array notation. So we have a local I as an integer. And what we want to do is to go through every element in the array, and we already know the code to do this. While I is less than bar a bar, do and while, and then we say I gets I plus 1. So this way I is going to go through every index that is applicable in this array. What we want to do is to do something like this. A bracket I is going to be something that can be drawn. Okay, and then we want to say just go ahead and invoke the draw member subroutine so that each object can draw itself. Now, but in order for this to work, we have some really tricky cases here, because in order to initialize the array A, we're going to say sometimes we'll have A bracket 0 gets, in this case, let's say R, which is a rotatable shape. Or okay, let me just change this a little bit here. We have a line. Let's say we have a circle, and so on. So we'll just have two of these. So we want the first one to be a circle, and then we want the second one to be a line, like this. Now this is a problem for us without object-oriented programming, because this can never happen. Remember, what is one of the requirements of all the different elements of an array?
They have to be the same.
They have to be of the same type. Okay? And here we have a problem because a line is not a circle. They are not considered the same type. But they do have one thing in common. What is common between?
Shapes.
They are all shapes. Very good. So in object-oriented programming, instead of using a particular type, you can say A is an array of a type that is shared, that is the ancestor of all the other types that you want it to contain. Okay, so in this case, it is okay now. Okay, if you look at this assignment statement, without object-oriented programming, we can complain and say, oh, that's not possible because a bracket 0, the left-hand side of the assignment, is expecting a shape, whereas the right-hand side, CIR, which is a circle, has a circle type. They are not the same without object-oriented programming. But with object-oriented programming, this is now permissible because the right-hand side only has to be what we call a subtype or subclass of the left-hand side. It doesn't go the other way around, it only goes in this direction. In other words, you can only get more abstract, you can only move up the inheritance tree as you perform these assignment statements. But it is possible. But what about that display thing? I mean, what about this draw subroutine? Who is going to define it? Well, we got two separate issues here. One is we have to kind of make sure that draw is something that is defined in a shape so that when we have a statement like this, it doesn't cause any problems. Well, that's not difficult to do. We go back to shape here, and then what we'll do is we'll say define, but in this case, virtual sub draw. Okay? Now that's a different thing than defining an actual thing, because without knowing exactly what shape I'm dealing with, I don't know exactly how to draw it. In this case, I'm defining this as a quote-unquote virtual subroutine, which is basically a slot. It is a reminder and say, okay, for all the actual shapes, we need to know how to draw them.
It's an abstract.
It is an abstract method. Yep. So later on, when we define a circle, now we have to define a regular sub of draw, and now we specify the code to draw a circle and define sub. So the programming language will automatically recognize and say, oh, a circle is eventually a shape, so I'm expecting a draw subroutine here, and here is the actual draw subroutine. So later on, when we actually utilize it, this will actually go back to the right method. Depending on which shape you're dealing with, it will actually go ahead and invoke the correct draw method for that particular shape.
So we'll know the difference between rotatable shape draw and circle draw subroutines.
Right. Well, a rotatable shape probably does not have a draw definition, because just because you know the shape is rotatable doesn't mean that you already know how to draw it. So it has to be, by the time you get to, it's a rectangle, a square, or a triangle, then you can actually specify the draw method, because only when you know what shape you're dealing with can you actually specify the logic you draw.
Right, but I'm just saying you would know which one to go to, so we'll
Yes.
say a circle or a triangle,
Yep.
you would know which of those to call on.
Exactly. So the best analogy I can come up with, in order to make this, something that we can all relate to and understand, is you're a stage manager of a talent show. Okay? So imagine this code here. I'll just kind of highlight the code here. This is the code of a stage manager in a talent show, or freak show if you want, to make it more fun. Okay, so with a freak show, what type of people or performers do you want to involve here?
Freaks.
Freaks of all kinds, but let's talk. So freak is our super class, right? Freak is the overall category. Okay, so let's go ahead and do this part. I know you guys enjoy this. Okay, so we'll go ahead and say record, but in this case, we're going to say class. Okay, when we switch from pre-object-oriented programming to object-oriented programming, we are switching the words a little bit. Record becomes class. Okay, that's just a term. It really is still meaning pretty much the same thing, but in object-oriented programming, we call these things classes. So we say class freak and define class and class. Okay, so a freak is probably a person, so we'll define person somewhere else with name, gender, and stuff like that. Okay, but freaks probably have something else that that makes that person a freak, right? Talent. Okay. Now the talent part cannot be specified here, but we can probably define something like this. We can say talent description, and it is text. Okay. In other words, a normal person would not have a talent description, but the freak, which is also a person, is going to have the extra member to remember the super talent that the freak has. Is that okay? Okay. Now, but there are different freaks, right? There are freaks is an overall general class. So now we can define the subclasses of freaks. Give me some examples.
Bearded lady. Bearded lady.
Beard lady. But
I think that would be an example of
how's that? Geek class is a freak. Okay. Now there's one thing I forgot to do here. Okay. With a normal person, okay, we are not expecting the normal person to be able to perform a freak act, right? But all freaks can perform freak acts. Is that okay? So that means when we define the class freak, we also have to define virtual sub, or if you prefer, either you can use virtual or what is the other way? Abstract. These are different ways to refer to the same thing. Abstract subroutine, we'll say freak act. Okay, which means but we cannot define the actual detail yet, because without knowing the type of freak, we cannot actually define the act because we don't know what it is. But by the time we get to geek here, we can say define sub freak act and define sub, and here we can specify how to chew the head off of a live chicken.
That's what geek is.
Look it up. That's how geek is defined, or one of the examples of quote unquote geek can do under the old definition of the word geek. Okay, obviously these days it's not the same. Okay, are we doing okay so far? Name other types of freaks.
Class either.
Class.
Warlock.
What?
From the time machine, she was Warlock, the underground Evermore.
I'll just choose a random name here. Okay, nail nose is a freak. Now this is a different type of freak, so it has a different subroutine here. So the freak act, which is still the same subroutine name because they have to be the same name, but the actual procedure or the actual logic that is specified here is going to be different. This one will be pound nails into nose. Okay. Okay. So we have a whole different a whole family of subclasses of freaks. Okay. So now when you actually specify the stage manager kind of thing, so you can say define manage stage, freak stage. So this is a subroutine, right?